You see it clinging to a tomato stake, perfectly still, triangular head turned toward you as if it knows you are there. The front legs are folded together. The body is long, angular, almost alien. Your first instinct may be simple. That thing looks dangerous, and you do not want it crawling through your vegetables. So your hand reaches for a shoe, a tool, or a spray bottle. Wait a second. The animal you are about to remove is not eating your tomatoes. It is waiting for something that is. A praying mantis is an ambush predator, an animal that stays concealed until prey moves within striking distance, and both its immature nymphs and its adults hunt other arthropods. It can take flies, moths, grasshoppers, leafhoppers, caterpillars, stink bugs, wasps, spiders, and many other creatures small enough for it to overpower. Kill the predator, lose the patrol. But there is an important scientific correction to the dramatic version of that idea. The mantis is not literally your garden's single best pest control species. Mantises are generalists, meaning they attack many kinds of prey without distinguishing a crop pest from a pollinator or another beneficial insect. Their value is real, but it is part of a larger living defense system that also includes lady beetles, lacewings, parasitoid wasps, ground beetles, predatory bugs, spiders, and birds. What you are looking at is not a magical exterminator, it is something more interesting. A large natural hunter occupying one position in your garden food web. And once you understand how it hunts, what its presence tells you, and when you should actually intervene, that strange insect starts to look very different. Insect: Carolina mantis, Stagmomantis carolina, along with several other mantis species commonly encountered in the United States. That distinction matters because praying mantis is not one species. The native Carolina mantis occurs across much of the eastern and central United States, while the Chinese mantis, Tenodera sinensis, and European mantis, Mantis religiosa, are introduced species now established in parts of the country. If the mantis in your yard looks enormous, the Chinese mantis is a likely candidate in many regions. Adults can exceed 4 inches, or roughly 10 centimeters in length, while the Carolina mantis is generally much smaller, around 1.5 to 2.5 inches, or approximately 4 to 6 centimeters. All share the same unmistakable equipment: a mobile triangular head, large compound eyes, an elongated prothorax, which is the neck-like first segment of the thorax, and raptorial forelegs, meaning front legs modified into spined, grasping weapons. Those folded legs are not hands held in prayer. They are traps under tension. The mantis is also not a grasshopper, although both may have long bodies and powerful legs. And it is not a walking stick, whose survival strategy depends mainly on plant-like camouflage rather than active predation. A mantis belongs to the insect order Mantodea, a lineage specialized for hunting. Depending on the species and sex, adults may fly well, poorly, or barely at all. Males are often lighter and more mobile. Large, egg-heavy females can be far less willing to take flight. What all of them have in common is that your vegetable foliage is usually scenery, not food. When you watch a mantis sit motionless for minutes, it can look as though nothing is happening. The opposite is true. The animal is waiting for movement to enter a narrow zone where one rapid extension of those forelegs can end the chase before it begins. A mantis does not need to outrun a moth across your yard. It lets the moth come to the flower. It does not need to patrol every tomato leaf looking for a caterpillar. It positions itself where prey traffic is predictable, then uses camouflage and stillness to shorten the attack distance. When the prey comes close enough, the front legs unfold and close around it, and rows of spines help prevent escape. The mantis then begins feeding with chewing mouthparts, often while the prey is still restrained. A small nymph starts with correspondingly small prey, including gnats, tiny flies, aphids, and other soft-bodied insects. As it grows through repeated molts or shedding of the rigid external skeleton, its prey range expands. A large adult can capture substantial moths, grasshoppers, stink bugs, bees, wasps, spiders, and large caterpillars. Chinese mantises have even been documented taking tiny vertebrates, such as hummingbirds, which tells you how powerful a large mantis can be relative to its body size, but also why calling it an indiscriminate protector would be misleading. Now look at your plants. You may see torn leaves and blame the large insect sitting nearby. Wait a second. A mantis does not normally produce feeding damage on living garden foliage because it is a predator, not a plant eater. That makes the damage pattern itself useful evidence. If a tomato leaf has sections missing and you find dark pellet-like droppings underneath, search for a caterpillar, such as a tobacco hornworm, Manduca sexta, or tomato hornworm, Manduca quinquemaculata. Their powerful chewing mouthparts can remove entire leaflets and stems, leaving obvious defoliation rather than tiny punctures. If lettuce, hosta, or strawberry foliage has ragged holes and a shiny mucus trail nearby, a slug is a stronger suspect. The slime trail is the clue a caterpillar and mantis do not leave. If tender growth curls inward while leaf surfaces become sticky with honeydew, which is sugary liquid waste, inspect the undersides for clusters of aphids rather than accusing the mantis. Aphids use piercing mouthparts to remove plant sap and can produce distorted leaves without cutting large holes. If you find neat or irregular chewed edges, frass, slime, leaf mines, stippling, or colonies of sap feeders, the mantis sitting beside the damage is often there for the same reason you are. Something edible has discovered your plant. The predator can become the suspect simply because it is large enough for you to notice. The life cycle makes that role even more interesting. In much of the United States, adult mantises become conspicuous in late summer and fall after spending months growing from tiny nymphs. A female produces an ootheca, an egg case made from a frothy secretion that hardens around dozens or even hundreds of eggs, depending on the species. The ootheca may be attached to a twig, dried plant stem, fence, rock, siding, or another stable surface. The adults generally die as cold weather arrives, but the eggs remain protected through winter. When temperatures and seasonal conditions are appropriate in spring, miniature mantises emerge. They do not receive parental care. From the first days of life, they must hunt, avoid predators, and avoid one another because cannibalism can occur. Survival is low, which is one reason seeing a single adult in August does not mean hundreds of mantises are controlling every corner of your yard. That adult is one survivor of a highly selective season. Its ecological job is not to eliminate prey. If predators eliminated all prey, they would eliminate their own food supply. Instead, predator and prey populations continuously interact, and your garden becomes a shifting network rather than a sterile battlefield. You spot a mantis beside a damaged pepper plant and think you have found the answer to every pest problem. Wait a second. This is where the biology becomes more useful than the myth. Mantises absolutely consume pest species, but university extension programs caution that they have limited value as deliberate biological control agents because they eat beneficial insects as readily as pests. A mantis may catch a cabbage moth or grasshopper in the morning and a honeybee or syrphid fly in the afternoon. That does not make it bad. It makes it a generalist predator. In a functioning garden, generalists can suppress individual prey they encounter, while more specialized natural enemies do different jobs. Lady beetles and lacewing larvae can attack dense colonies of aphids. Tiny parasitoid wasps can place their offspring in specific caterpillars or aphids. Ground beetles work near the soil surface at night. A mantis occupies a different hunting space, often intercepting larger mobile prey on stems, flowers, shrubs, and tall vegetation. Consider one tomato plant. A mantis positioned among the stems might catch a moth before that moth lays eggs, or it may encounter a young hornworm and remove it. That is free predation, occurring without you applying anything to the plant. But if 20% of that tomato's foliage has already been removed by hornworms and more feeding is likely, that crosses an established integrated pest management treatment threshold used for tomatoes. At that point, hoping one mantis will solve the outbreak is not a management plan. Inspect the plant, hand-pick hornworms where practical, and use a selective treatment only when necessary. The same logic applies to aphids. A few clusters with no distortion may require nothing because lady beetles, lacewings, syrphid larvae, parasitoid wasps, birds and other enemies often reduce them naturally. But when you see widespread curled or yellowed growth, stunted shoots, sticky honeydew coating leaves, or an expanding colony protected by ants, you have evidence that predation is not keeping pace. The key is not counting on one hero predator. The key is allowing an entire predator community to work until plant damage shows that it cannot. That is also where chemical pest control creates a trade-off you can actually see. A broad-spectrum insecticide, meaning a chemical capable of killing many different insect groups rather than one narrow target, can knock down a pest rapidly. It can also kill the predators and parasitoids that would have continued working after the spray dried. A mantis never covers every leaf, but it also does not create pesticide residue across every leaf. It hunts one prey animal at a time. A parasitoid wasp works differently. A lacewing works differently. A lady beetle works differently. Together, those predators provide continuous pressure across multiple parts of your garden. Chemical control has a place when pest pressure exceeds a meaningful threshold, but the presence of predators is one reason integrated pest management starts with observation rather than automatic spraying. If one hornworm is chewing a tomato plant and you can remove it by hand, a whole yard insecticide would be an ecological overreaction. You would be trading one visible pest for the loss of multiple invisible allies. Then the mantis turns its head toward you. You see the spines, you see the jaws. Your brain makes the obvious calculation. If it can hold a grasshopper, what happens if it grabs you? Wait a second. Praying mantises are not medically important venomous insects. They do not have a stinger, and they do not possess a venom delivery system comparable to a bee, wasp, or venomous spider. A large mantis can defend itself when handled and may pinch with its forelegs or bite with its mouthparts, so there is no reason to squeeze one in your bare hand. But an animal defending itself after being grabbed is very different from an animal hunting you. You are thousands of times too large to be normal prey. If a mantis suddenly flies from a plant, especially a mobile adult male, that movement is not evidence of an attack strategy. Flight is transportation and escape. The animal may be moving toward vegetation, light, a mate, or simply away from disturbance. There is one situation in which the predator deserves extra attention. A very large mantis, repeatedly stationed beside a hummingbird feeder, is not necessarily there for mosquitoes. Flowers and feeders concentrate traffic, including bees, wasps, butterflies, flies, and hummingbirds. Large Chinese mantises have been documented capturing hummingbirds, so if one is sitting directly on a feeder or immediately beside the feeding ports, relocation is sensible. That is the difference between understanding an animal and turning it into a mascot. You do not have to kill the mantis, and you do not have to pretend it can do no harm. Move it to dense vegetation away from the feeder, and let the food web continue somewhere more appropriate. Now suppose you keep seeing mantises in one section of your yard. Your reaction may be, "I have a mantis problem." Wait a second. Predators usually accumulate where food and structure make hunting possible. If you see a mantis repeatedly occupying your beans, tomatoes, shrubs, or flowering borders, that tells you the area is producing enough arthropod traffic to support an ambush hunter. Look around it. Check leaf undersides. Examine fresh chewing. Watch flowers for moths and flies. Search stems for leafhoppers and aphids. A mantis is not proof of one particular pest species, but it is a biological signal that your yard contains prey and enough habitat complexity for a large predator to persist. Its presence can also indicate something positive. You have not turned every plant surface into a pesticide-treated dead zone. The same detective logic works with the egg cases. If you discover a hardened Mantis Ootheca attached to a dried stem in winter, your first impulse may be to prune everything clean and throw it away. Wait a second. That small structure is next season's predator generation. Native Carolina Mantis oothecae are typically smaller and flatter than the larger foam-like cases of Chinese mantises. If the stem is not creating a genuine maintenance problem, leaving it outdoors preserves the normal seasonal cycle. Do not bring the egg case into a heated house. Warm indoor temperatures can trigger premature hatching when there is almost no prey available, leaving dozens of nymphs with nowhere useful to go. Habitat conservation can be as simple as delaying aggressive cleanup and allowing stems, leaf litter, shrubs, and ground cover to remain in parts of the landscape. So, what should you actually do when a praying mantis appears in your yard? You have 3 sensible options. First, leave it. If it is resting on a vegetable plant, shrub, fence, flower bed, or ornamental grass and creating no specific conflict, doing nothing is usually the most ecologically useful response. Watch it hunt. Avoid spraying broad-spectrum insecticide around it merely because you also noticed a few damaged leaves. Identify the organism causing the damage first. Second, relocate it when the location creates a real conflict. If a large mantis is repeatedly hunting directly on a hummingbird feeder, doorway, children's play area, or another place where you do not want it, encourage it onto a container, branch, or sturdy object, and move it into dense vegetation away from the problem location. There is no benefit in grabbing the animal tightly. Give the forelegs room and let it step onto the object. Third, fix the root cause when plant damage has crossed from cosmetic to meaningful. If your tomato has one chewed leaflet, inspect it. If hornworms are approaching 20% defoliation and still have the potential to keep feeding, act instead of expecting one predator to reverse the damage. If aphids have moved beyond a few tolerated colonies and you now see widespread curled leaves, yellowing, dead or stunted shoots, heavy honeydew, or declining growth, use physical removal, such as a firm water spray where appropriate, and escalate only as needed. The visual threshold matters more than your fear of the insect standing nearby. A mantis on a damaged plant is not evidence that the mantis caused the damage. And remember the larger threshold on the other side. A predator becomes a management concern, not because you see one mantis or two, or even because you witness one eat a bee. Predators naturally consume other beneficial species. Intervention becomes reasonable when a particular individual is repeatedly exploiting a sensitive concentration point, such as a hummingbird feeder, or when management guidance in your region calls for controlling a non-native species. Otherwise, indiscriminately killing mantises simply removes another predator, without solving the pest population that attracted predators in the first place. That is the part of garden ecology that is easy to miss. You notice the mantis because it is 4 inches long and shaped like something from another planet. You do not notice the tiny parasitoid wasp searching a caterpillar. You may not notice the ground beetle hunting after midnight, or the lacewing larva under a curled leaf. Yet, your garden is filled with these interactions every day. When you replace that network with routine insecticide applications, you do not merely kill the creature eating your basil. You can remove the creatures eating the creature eating your basil. So when that mantis turns its head and watches you from the tomato cage, resist the assumption that every unfamiliar insect requires a response. Identify first. Look at the damage. Find the actual feeder. Decide whether the damage has crossed a real threshold. Then choose the smallest intervention that solves the problem. The praying mantis is not a flawless guardian and not necessarily your single best predator. It is something scientifically more valuable than that slogan suggests. One visible member of an entire biological control system already operating in your yard for free. Kill it automatically, and you have not made your garden safer. You have simply removed one hunter from a landscape that still contains prey. Have you ever run into a praying mantis in your own home? Tell me in the comments. I read every one. If you want to know who else is living in your house, subscribe. Next time, we will look at another creature people eliminate on sight, even though its nightly hunting may be protecting the plants right outside their door. See you in the next episode.